the screen here, and that's going to be about slice of pizza on your right. We're just going to get started with announcements here in 30 seconds. And if that's the case, I might count it down live here just to be fun. Everybody knows that. Awesome. We should put on really awesome. Yeah, it's just like 5 years to do that. Awesome. Hi, everybody. Thanks for coming out here. This is JavaScript MN. If you're looking for another welcome, you're now JavaScript MN. We've got an awesome Wi-Fi network provider. We were here. It's super ridiculously fast. As you guys are seeing, feel free to sign in to be our guests. There's no hassle. Just get some cool, some fun. I'm Brandon Johnson.
I'm Anna Baker.
And we are half of the organizing team for JSMN. It's Mary and Brian are otherwise engaged tonight over here. We're going to have a call dinner. We would like to mention that at our events and our online spaces, we have a code of conduct because we're all committed to having an event that's free of harassment along any lines. If you have any questions about that, we invite all our attendees and speakers, and of course we're going to just read the code of conduct on our website. If you have any questions or concerns about this, reach out to us. Anna and I, of course, are maybe the most visible people IRL right now. But if you would like to make any feedback or any reports to us, email us at javascriptdemand@gmail.com, and all of that is confidential. I'd like to thank our sponsors, starting with our host, WeWork. So WeWork's been our host for a couple months now, and they've been so awesome. If y'all haven't heard of WeWork before, it's a co-working space, not unlike the place you're sitting in right now. And occasionally we have somebody from WeWork who might want to say a few words, but if they can have us.
All of them properly heard.
Awesome. Thanks so much. Can we get a round of applause for WeWork? It's so helpful. Thank you. Yeah, since we moved our events here, it's just been such a breeze to get everything set up. They've graciously provided beverages tonight too. Feel free to grab some of the food, water, it's the best. That's all I can say about that. We're just gonna go. We're gonna go fast. We're gonna go fast. That's right. Twilio is a provider of telecommunication APIs. You all saw all the signs outside. We have a text chatbot of sorts that you can text, and it will let Anna and I know if you're outside, if you're looking for the venue, say track down. That's sort of the Twilio does. So if you want to do anything related to telephones, text messaging, this newfangled thing kids are talking about called MMS, multimedia messaging. Twilio is your very house. We also want to thank Track.js, a local company that provides JavaScript error monitoring services. They're actually based in Stillwater, which is cool, but they've been such a great supporter of this community. So if you're looking for JavaScript error monitoring services, and aren't we all, you should check out Track.js. We also want to thank the front-end masters, who provides really high-quality training related to web development, whether it's JavaScript, CSS, or HTML. They've got all the best frameworks and all the cool people from the frameworks, the React kids and the Vue kids. Sarah drives in there, has like half a dozen of my favorite courses in the universe related to SVG integration, CSS, the language, and Vue to boot. And that's the kind of thing that Masters has. So if you're looking for that kind of training, feel free to check them out. And we'd also like to thank C.H. Robinson. Hey, Evan. Our speaker tonight is from C.H. Robinson. C.H. Robinson has been a strong supporter of this group for a couple of years now, and we've been so grateful for their support. They're a third-party logistics provider with operations in Eden Prairie, headquarters in Eden Prairie, I should say, and an extremely deep and experienced technical organization, and we really appreciate that they continue to support us. We also wanted to give a quick shout out to all the places you can find us on the internet. JavaScriptInternet.com is our website where we post information about Meetup. This is being streamed right now live via the interwebs with this little buddy right here. So if you shout out to everyone who's watching this live stream. If you can't make it to one of our events, that can be a cool way to chime in and see what folks are talking about. We also have a Slack, which you can hop on via our website. There's an auto inviter there where we can talk about this stuff, announce events, talk about if folks have questions about code or other events that might be interested in. Slack's where that happens. We also tweet about this stuff on our Twitter, JavaScript event, where we post new event notifications and stuff like that. We'd also like to take a moment to invite everyone here to everyone here has something that they're excited about. Something that they're excited about related to JavaScript, maybe not related to JavaScript. But if you have an idea that you think would be a good fit for this group, we'd like to invite you to reach out to us because we'd love to have you here. No matter what your experience level is or familiarity with JavaScript, we often have speakers who don't work in JavaScript at all. That's totally okay. Because the thing that's cool is that you're standing up here to share something with the group, which is super awesome. Talks kind of range from 5 minutes to 10 minutes, all the way to 1 hour. And we plan an event around y'all, not the other way around. So there's no idea too small or too big. Just please reach out to us. I gave my first talk here when I was a student. I hadn't had any programming experience whatsoever. And it was a super awesome experience. We have one of the kindest and most generous audiences in Minnesota Tech, and we really appreciate it. That's all of you. Thanks for being here. Now we'd like to open the floor for announcements. So this could be if you know of an event that's coming up, say mini demo is coming up in a couple of weeks. And you can find mini demo at ministart.org. There'll be tickets and announcements that will be there in a couple of weeks. If you are looking for work, or if you have a position open and would like to share it with the group, now's the time you can raise your hand and any of that kind of thing. That's looking for work, positions open, and opportunity to share. Going once, going twice. Jason, I'll invite you.
Hi, I'm Jason Su, looking for a position involving Ruby on Rails. And be sure to check out my website, rubyonracetracks.com. The tactics are weird, but they're far more effective for me. The normal way just didn't work out for me at all. So check out rubyonracetracks.com, as well as legacyrailsapps.com and other affiliate sites you'll find on the links page.
Awesome. Thanks, Jason. All right. Any other announcements that you're liking now? That's all right. I'll throw one other shout out there. Minneapolis Junior Devs Group. I don't know if y'all have heard about the Junior Devs Group. It's a super awesome group aimed at new and aspiring developers in the Twin Cities community. They're having a meetup on July 16 at Prime Digital Academy downtown. So you go to mplsjrdubs.com. You can find out more about that and get tickets. It's super cool. Awesome. Next month, we have another exciting talk. David Stanch from IBM is going to be coming up from Rochester to give a talk about moving from frameworks to web components. There's been a big discussion in the JavaScript community over the past couple of weeks about this, so it's going to be a really exciting talk, and we'll see you there. Next up, we're going to move to lightning talks. So if you all remember from a couple slides ago, these are the 5 to 10 minute demos or short talks around something folks want to share. We probably have for we have one lightning talk already scheduled, but we'll probably have room for one more. So this is you, even if you don't have any slides or anything, you just want to share a cool link. Now's the time to be thinking about it because we will have a chance for you all to maybe share it. But first, I want to call Anthony. He's going to give us a demo of how he's working on it. Yeah, go for it. All right, can you get over the full screen? This guy, sorry.
Yeah. Louder. Louder. Are you guys familiar with the Odin project at all? So basically, it's just like a free boot camp for beginner developers. They're going to be like, it's like a course for implementing simple projects and stuff. So one of the projects that I made was like an etch a sketch, and that's just what the Odin project gave. And I'm going to show you the live version if it pulls up. Guys, it's just one for some reason. Would it be okay if I just connect this again? Okay, so yeah, it's a simple project, but like I learned a lot from this. Thank you. So yeah, I know this is probably being a little buggy. It's only going to show on this, but I can't move the mouse. So just do it real quick. Sorry about that. But yeah, basically, the project, like I said, it's like a free boot camp where game developers can use to make projects. So what I built was an etch a sketch, and it's not completely done, but I've had people that's helped me, like Stack Overflow. Thank you so much. And I've learned a lot. Like I suffer from like being insecure about being a sucky programmer. I don't have all the answers to everything. I wish I did. Like I've only been programming for about 6 or 7 months, and I just struggle a lot. Saying like I compare myself to other developers, saying, "Oh crap, he's so good. How is he able to do that? He's building like good applications that can help people, but I'm building this." But like I learned a lot. Like I've been able to ask good questions. Like I read this blog post like how did I waste people's time to ask good questions. Took notes on it. I did a lot of things, especially use Stack Overflow. Like, I don't use it a lot because if I do, I feel like I'm dumb. I'm asking questions. Like, oh, I can't do that. So yeah, yesterday it was like I was like, Brandon, I need help with this. Like on Stack Overflow, not Stack Overflow, the site. It's like help me. I need help. I don't know how to do this. And he solved my problem in 6 minutes. And it took me 2 days to even like know how. I didn't even know how to solve it. I was just like, okay, what am I doing? Like this sucks. I want to give up now. And like, I wish I could show you how it would work, but like I said, it's just the adapter is just slowing down. I'm not gonna fix that. Yeah, and then I will show you how GitHub pages. So, Grant's doing something.
We'll let you do that.
Okay. But yeah, again, I learned a lot doing this project, and I worked with jQuery. Oh, nobody uses it, but I've only. But I learned a lot from Team Treehouse. And it was like a course that we were teaching jQuery, and I was like, okay, so I'm just learn that. And that's what I did like 5 days, and I did mostly everything in jQuery, and I was just learning it from my mistakes. And yeah, so basically with the gradient, all it does is like you move over the boxes, the opacity be low percentage. But if you move over the mouse again, the opacity will be higher. So that's basically what the gradient does. Random, if you move your mouse over, it will just turn into a random color. And unfortunately, I had to look that up on Stack Overflow too, because I guess I'm not smart enough. But yeah, on the reset one, you know, it just basically uses the whole thing to be transparent and just look like this again. Now, this is my problem. Resizing the grid, so that if I did like 17, it'll delete this original grid, and then it'll be 17 times 17 column grid. So that's what I'm trying to fix right now, and I've been trying to add Stack Overflow, but they've been ignoring me. I don't know if that's common or not. It kind of sucks. It sounds smart, actually. So yeah, any questions? Because I'm going to show you guys. Oh, I've actually put it up. So, okay, so this is what I mean by opacity increasing. It's kind of near touching the mouse, but yeah. So that's what I mean by random. So yeah, small application, but to me, this is like a big goal, and I think it's awesome. But other people have made it better, and just like, wow, I need to do that. And like, I always try to work on hard projects that are going to test my knowledge and how to do stuff. And especially on the ON website, you guys should check it out. You can come up with a Node.js course too. But yeah, basically, you know, I struggle a lot. That's but I accept that, and I kind of just want to be the small fish. Like a big power I can absorb everybody's knowledge and just learn new things. And I think that's it. Like, thank you. Yeah.
No, it's all good. It's all good. Thanks, Anthony. That's awesome. I'm so glad to have you here and sharing with us. It's been awesome to see kind of as these projects progress. Congrats, dude. Congrats. Awesome. So we've got one lightning talk under our belt. Anyone else want to share something with the group for a couple minutes? No? That's all right. That's all right.
I'd share something.
Hey, go for it.
Yeah. I would just echo that. Is that Anthony?
Yes.
Anthony, awesome. Kudos for getting up here and sharing your thoughts too, because imposter syndrome is a real thing. I suffer from it every day. I get up here and talk to you guys to try and help myself overcome it. So, awesome. Kudos. Also, there's nothing wrong with jQuery either. It's still the #1 downloaded tool in the world. Maybe not a lot of new code written with it, but it's still very, very prolific, very prevalent. So, no sweat. I love jQuery.
Well, awesome. Cool. Well, we're going to take a quick break if that's cool, and probably about 10 minutes. So if y'all want to get some pizza, get some salad, make sure to get a brownie if you like sweets. Feel free to have some cool, awesome conversations too while we get that set up for our main presentation tonight about text coverage for IstanbulJS. See y'all in a couple minutes. Awesome. Hey, I totally forgot about this. Like, this is your lavalier.
Oh, that would all my gifts for me?
This is for the video.
Oh, I think it's good when more people like balanced perspective on.
Thanks for finding your seats, everybody. And so that your conversation Hey, what's up? Thank you. Awesome. I'm not terribly authoritative, even when I have a microphone, so I appreciate y'all bearing with me. Awesome. Well, thanks so much for being here again, everybody. And I've said more than enough for tonight. So I'm going to welcome.
Good evening, Evan Bremer of C.H. Robinson. And allow him to commence his talk.
All right. So I need both mics?
Yes.
Very good.
Feel free to carry.
Yeah, it's going to get awkward if I'm like doing this and craning my neck and, all right. So one trick I learned is if you treat your mic kind of like an ice cream, works out pretty well. So thank you guys for showing up. Thank you for listening because I've got a lot to say. I hope I can cover it in 54 minutes. I'm going to try to talk as quickly as I can without losing you guys. But those of you who've worked with me, hi Guy, holy smokes. I know a few people in the audience apparently. Those of you who have worked with me know, case in point, I'm getting a little long-winded. So I'm sure your first question is, who is this guy? And what makes him think he's qualified to be up here and lecture at you guys? My name is Evan Bremer. I currently am an architect at C.H. Robinson. I have a family and stuff. Not a lot of hobbies because if you have kids, you can relate. I just go home at the end of the day and hang out with the family and then go to bed. Sometimes I have to do laundry and wash dishes. It's not very exciting. But enough about me. We're here to talk about some JavaScript. And I'm here to hopefully teach you guys a thing or two. So I'd like to address you directly. I'm going to bet most of you are app devs. OK? Is that true? Mostly nods. Good, I nailed it. All right, so you built this amazing app, OK? It's got the most modern architecture. It's got the best practices implemented, and it's got the modern tooling, the latest version of the latest framework, and it's just amazing, right? And it performs really well. It handles thousands of requests per second, and it's got throughput, and the time to interactive is sub-second. It's just top notch, right? It renders beautifully at all resolutions and orientations and DPI, and it works upside down and underwater. It's amazing. And you tell your supervisors and your colleagues, trust me, it's ready to be deployed, okay? Let's get it out there. Let's get it in front of users. All right? It's ready to go. I tested it. It's ready. All right? Like I said, most of you guys are app devs, so what am I going to talk to you guys about tonight? Your number one job as an app dev is to get your product to production in front of users as quickly, easily, expediently, all those other Lee's words, as possible, okay? What that also entails, you need some automation, right? So you're probably going to engage with your DevOps or DevSecOps or your continuity or your QA operations folks, and maybe you work at a smaller company or startup and that's you're deploying your own code, in which case you just put on your DevSecOps hat and then you talk to yourself. Either way, you're gonna ask the app dev in this scenario a question. Please give me some reassurance that this thing is not just going to blow up when I put it in front of users, all right? And if you're lucky, they'll use the word please. So you say, cool, I'll go write some more. I'll go write some tests. That should be enough, right? Well, sometimes. Trouble is, writing the tests alone is usually not enough, okay? What we really, really need is some objective proof that can be analyzed by a tool. And if you meet some objective threshold, that's what qualifies your product as good enough. As I mentioned in the description for this talk, objective proof it's not foolproof, and it's certainly no replacement for a good peer review, but sometimes it's all we've got. So that begs the question, how do I generate such a report? How do I get my code covered, and how do I report on that? And how do I know whether I've reached that threshold? And you're going to run into some problems along the way. There's some scenarios that current tooling in the ecosystem just kind of doesn't support, or doesn't support very well or very comprehensively. So we might have to start getting a little creative, okay? So before we move on, I want to make sure that we all have kind of a common understanding of common testing terms, and I want to make sure we're talking like a ubiquitous language here. Baseline glossary is kind of established. When I talk about testing, there are 3 types of tests in general. There's unit tests, integration tests, and end-to-end tests. Units are when you test a single piece of code in complete isolation, and all of its dependencies are stubbed or mocked. And you pass in test data, and you get some test results out of that unit. An integration test is when you just tie some units together and you no longer stub all of their dependencies. You let the dependencies talk to one another. And an end-to-end test is when you let the whole system or the whole application, including downstream dependencies, exercise, okay? We're also going to assume a kind of mantra when we write our unit tests and our integration and end-to-end tests for that matter. We will arrange, as in set up our scenario. We will act, as in cause the scenario to execute. And then we will assert that the right thing just happened as a result of executing our scenario. Okay? So let's start from basically ground zero. The ultimate goal here is for you guys to have a stronger appreciation for what tools exist, how they interoperate, and maybe a little bit about why they're built the way that they're built, okay? So if you guys have a laptop, feel free to follow along. I put together a GitHub repo where you guys can clone it and kind of follow along as I move through the slide deck tonight. It starts as a simple Node.js module. And I promise it will get more interesting as the talk proceeds. I just needed a really trivial example so that I didn't lose any of you guys. Also, there's pizza, so please don't leave. Is there pizza? Looks like we've got mostly empties, but there might still be pizza in the back. All right? So if you want to follow along, go to github.com/EvanBB, that's me, /js-mn-IstanbulJS. I'll give you 20 seconds to pull that up and clone it down. Good.
I'm also loading in Slack, so if you're in Slack, that's the place to get.
Sweet. I also linked to these slides, so if you do have an emergency and need to jet, you guys can just read my slides, and good luck understanding what I said. Ha ha ha. So, like I said, I'll go ahead and show you guys what is in that repo, starting from the initial commit. It starts with a single module with a single unit. This is going to be trickier than I thought. Yeah, nailed it. All right, so now I've got a whole bunch of stuff in my pending changes because I don't have a git ignore in here anyways. So it thinks my node modules are part of my pending changes. Let's expand source and take a peek at index.js. Who can tell me what this function does? You nailed it. I have adopted intention-revealing naming. Uncle Bob would be so proud. All right, so this is my module. Like I said, we've been asked to write some tests, okay? So, in order to write a test, the most naive way to do that is to create a test file. I'm a big fan of co-locating tests with your source code, so that's what you'll see as we move through this demo. Don't want to start that holy war, just preparing you guys for what you'll see. But then once we create a test file, we still need some way of invoking that module, because when we invoke that module, it will invoke our unit under test. So that's what we ultimately need. So once all of our files have been required and all of our units have been tested, we'll know that if node exits 0, that all of our tests passed, right? Oh man, I'm gonna have a really sore neck. Where's my branches there? Paste. Cool. So now I've got index.test. I require in my module, so I got my function. I call my module with some test data. So I've arranged, and then I've acted, and then I assert by just making sure that I got the right thing out of the function. Okay? Needless to say, this sucks. This is going to be really painful to manage at scale. What if my unit under test does more than just one thing? That's very possible. Who's written a module that does more than one thing? I should see everyone's hands. Play along. This is an interactive demo. What if I want to test different scenarios? Obviously, I'm just saying, you know, 2 positive integers here, 3 and 5. Should I test for negative values? Should I test for floats? Should I test for strings and other data types? What if I add a number and a date? All right. The way that we're invoking this test right now also kind of sucks. So if we look at our package.json, I've swapped out the test script to say node invoke test.js. Test.js, I'm using a tool called glob to go find all of my test.js files. And then I require them in. And if nothing threw an exception, we get a gold star. OK? We can do better. The very first step to getting better, oh yeah, we already got that over with. This is my first time doing this talk, so I'm still kind of getting used to how I built the deck. So bear with me. We want to use a tool that makes all this easier. Again, I'm not going to start a holy war about which test framework is the best. I like Jest. It's comprehensive. It solves a lot of problems, and it makes me, it helps me do my job easier. What makes Jest interesting is it is multiple things. It is a test runner. It's going to go out and... You're listening to me? I'm up here. It's a test runner. It's going to go and discover all of my tests for me so I don't have to maintain that code. And it's an assertion library. The assertion library that Jest provides actually builds right on top of Jasmine. So if you've used Jasmine before, you're going to find Jest really approachable. OK? So at what that would look like. Going to add Jest. Check out my next commit. And you can see test.js went the way of the buffalo. And now my test script is just invoke Jest. Jest is going to bank on a few different conventions. And one of my conventions, or one of the conventions that it looks for is anything that has .test.js in it. So all I did was swap out the guts of this file, and Jest is still able to discover it. As I said, the assertion library that Jest provides builds on top of Jasmine. This enables me to start grouping my expectations and my individual tests in a much more declarative, almost plain old English sort of way, which is really nice. So, Jest is just one option. There are lots of other test frameworks. Ava, Karma, Mocha, and Chai are great libraries. But what makes it really interesting from this point is all of them actually, under the hood, if they're capable of generating reports, use the same tool. And that tool is IstanbulJS. And that was in my title of my talk. So there's the punchline. All right. So the next follow-up question, I'm sure, is just on everyone's mind right now. Tell us more about Istanbul. How does it work? What does it do? What problem does it solve? What it does is collect and aggregate data about the units that were executed during a test run. And it does that by a process called instrumentation. Instrumentation, yeah, I'll let you guys check out my memes. I got a lot more. So, all right. There are lots of reasons that you might instrument your code. In our case, we're interested in test coverage, but you might instrument in order to analyze performance, or maybe build out a dependency graph, or whatever it is. You can instrument for lots of different purposes. In our case, what we're going to do is add some code to our code so that we can tell what code got executed. And that's how we'll generate test coverage. So let's take a look at how the module now looks. We want to generate a coverage report for the entirety of our code base, which means as our tests are executing, we need some global bucket to aggregate all of the coverage information as the tests are being executed. So at the top of this file, I'm just creating that global bucket. And into that global bucket, I'm saying for this particular file, this module, I might have functions, I might have lines, and I might have branches. Anytime a function gets executed, I'm going to increment its corresponding counter. Anytime a line gets executed, I'm going to increment the counter that refers to that line. Everyone still with me? It's only going to get uphill from here. By the same token, please keep your questions till the end, because I've got a lot more material to get through. All right. Needless to say, this is also going to suck at scale. What am I going to do if this is part of my source code? I don't want this in my source code. Even if I were to get really smart with it and have like a function that I swap out with a no-op when I deploy my code, this is still a real eyesore in my source code. I really just want to add the code for the duration of the test run, aggregate my coverage data, and then report on it, and then not have it be maintained. I really, again, need a tool to help make this job easier. And the de facto standard tool for this is IstanbulJS. So I'm going to add Istanbul. This commit right here just pulls all this junk out, so I'm going to skip that one. All right, so if we take a look at the package JSON, I added a script here called instrument. Instrument is going to invoke a tool called NYC, which is just a CLI wrapper on top of IstanbulJS. And I've told it to instrument my source and put it into the source instrumented directory. And if we look at the source instrumented directory, the corresponding index.js, now that it's been instrumented, has pretty much all the same stuff that I did manually, except a tool did it. Yay! It did a whole bunch more, though. I'm going to do some magic hand waves about the more and focus on the meat of this, which is the incrementing of the counters. Here, the 0th statement got executed because we exported something. That's a statement as far as this JavaScript program is concerned. Maybe under a certain circumstance, the thing that you're exporting wasn't the right thing, so that counts as a decision that this program made, so we better count it. Okay? It's also created this global variable that it can write to within the scope of this module and stubbed out on the global object, because that's what it is in Node. That'll be important a little later. The global, it's written to the coverage object, and it's put, it's put that on the global scope, just exactly the same way that I did it. If it doesn't already exist, stub it out to an empty object, and then keep track of it as the tests get executed. So, how does this all work? Imagine a world where there is a very simple JavaScript expression, a plus b. What we're going to do is take a string, a plus b, we're going to parse that string, and we're going to look for language constructs like curly brackets, parentheses, the function keyword. We're going to look for pieces of language that we recognize, and we're going to build a tree from the pieces that we recognize. And then the resulting tree, we're just going to call it an abstract syntax tree, or AST for short. Okay? This particular tree contains 3 nodes: a mathematical addition operator node and a left and right operand node. Not terribly interesting, but let's extend that same idea to a fuller program. Well, now we've got a function declaration node. The function declaration has an argument list, as well as a body. Inside that body, there might be blocks, there might be variable declarations, there might be all these other kinds of nodes. If we run it through a tool like IstanbulJS, the tool is just going to add those counters into the tree. It's just going to spell it out as a new assignment operator, and the assignment is ++, right? It's going to take the resulting tree, and then we can flatten it back into a new JavaScript program that's been instrumented with all those markers inserted into it. All good so far? I hope so. You can review this and the slides and the Git repo. All right. That's all well and good, but that means what's being executed at runtime is not my source code. How do I know which pieces of source code ended up in my runtime executable? Source maps are a piece of data that points from the resulting code at runtime back to the source code before it was transformed. In our case, the transformation that we did was instrumentation. What if the transformation that you did was run it through Babel, run it through TypeScript? What if it was take a whole bunch of modules and concatenate them together? What if you minified or obfuscated your code? Those are different transformations. A source map is optionally generated by lots of tools. In our case, IstanbulJS is capable of generating a source map after it's done instrumenting your code, so that you know if this line was executed at runtime, it actually came from this line of source. Keep that in the back of your head because it's going to play an important role at solving a problem no other tool currently solves. And I'll get to that towards the end of my talk. All right. You want to see it in action? Because I want to show it. All right, I'm going to fast forward to making Jest do a bunch more heavy lifting. So starting with package.json, I've swapped out my test script to invoke node with this special inspect break flag. What that's going to do is as soon as the node process starts, it's going to pause and wait for something to connect to it on the debug port. The script that I want it to invoke is Jest, and I want to pass Jest 2 important flags. One is coverage. This will tell Jest, when you pull in my tests, anything that my tests pull in, run them through Istanbul first. I also want Jest to run in band because I'm attaching a debugger. That's important because Jest by default will try to run multiple test modules in parallel, which means I might not be able to hit my debugger. So I'll go ahead and run npm test, and you can see in the terminal output, the debugger is listening on WebSocket local 9229. What this enables me to do is open up a new Chrome tab and go to Chrome. Inspect. And that popped up on my other monitor. And lo and behold, Jest hasn't even started executing yet. This is the CLI module that resolved by Node. Node has just
stopped execution and is waiting for the debug tool that's connected to it to continue execution. Let's take a quick look at my index file. I've added a debugger statement here. So when I continue execution of node, it's eventually going to run jest. Jest will discover my tests, and it's going to hit that debugger. What I want you guys to take note of is what you see when that happens, when that debugger is hit. So we can watch jest is now discovering my tests, starting to invoke them. I hit my debugger. If you look really, really carefully, you'll see this square bracket SM. That stands for source map. The source map is actually coming from IstanbulJS. Let's turn off JavaScript source maps. As soon as I do that, I'll see this is what is actually being invoked by Node right now. There's my coverage data. There's my debugger, and all my counters. And at the very bottom, there's this thing called source mapping URL. Because this is just for development right now, the entire source mapping data has been inlined as a base64 string. If I copy that, I'm going to set the mic down because it's really hard to type with one hand. You guys can see the source map information contains all of the names that were discovered during instrumentation that point to symbols that need to be resolved in the source code, plus the actual content of that source code. This magic mappings thing, I'm going to do more magic hand waves thing because it's really kind of nuts. Just know that that's how the symbols at runtime map back to the symbols in your source code. Good enough? I sure hope so, because I'm going to close this. All right. That's it for unit test coverage. That is how unit test coverage is calculated. We instrumented the code. We projected new code in its place with all the markers inserted where the functions are invoked and the branches are branched. All right, so let's take a look at what integration test coverage looks like. Oh. Oh, you think. All right, here's what we're going to do. All right. Where'd it go? There we go. Okay. It just takes a while. These Macs don't perform real well most times. All right, so in this commit, I added some consumer. Okay? The consumer, in this case, is going to require in add two things, and it's going to multiply two things by just iterating over an array of a length and agging them together. The consumer test, guess what? Looks a whole lot like our unit test. I'll save you guys the trouble. Running an integration test looks the same as an integration test, or as a unit test, because it is the same. You're just not mocking out dependencies. In this case, I'm pulling in the real sum consumer. The real sum consumer pulls in the real add two things. There's no magic here, okay? Instrumentation is going to be the same. Reporting is going to be the same. It's really not that interesting, so we're going to skip it. All right. So, how much time I got? Yeah, I'm in good shape. You might be saying, well, shoot, if integration tests are pretty much the same, then end-to-end tests are going to look the same too, right? No, sort of, kind of. What's the problem with end-to-end tests? In order to help you guys kind of understand why this is kind of a little different, or even a lot different, think about what has to happen to invoke end-to-end tests. In order to invoke an end-to-end test, which is, again, your full app talking to real dependencies, nothing is stubbed. This is what's going to production right now. In order to test that, you need to host it. So you need to throw it in IIS, throw it in a node server locally, and actually run the thing. However you host it, host it. Then in another process, use a tool like Protractor or Nightwatch or Puppeteer, spin up a browser, and interact with the thing. Okay? Use that tool to go to your web page, interact with it, click the buttons, fill out the form, watch the spinners, all that. And then usually those tools have some way of asserting that the right thing is rendered on the screen right now. So there's your arrange act assert. The trouble is, since the code is being served by this process and your test tool is running over in this process, there's no good handle, no good hook to instrument that code. So here's where we're going to get a little creative. Brace yourselves. It's going to get weird. All right? Let's solve this in a really quick and dirty way. What we're going to do is, in addition to deploying our app over there, we're going to deploy a copy of the app where our end-to-end tool is going to run. Then we're going to run NYC to instrument our app on the same machine where our end-to-end tool is running. Then we're going to configure that end-to-end tool to serve the instrumented code to itself. Instead of going over the wire and serving it from that other process, it's going to serve instrumented code to itself. All the other static assets, the HTML, the CSS, the JPEGs, all that's going to come from the real server, but we're going to instrument the JavaScript and serve it to the browser from the same browser's process. All right. After each test, we're going to inspect the page and rip out that global coverage data that was created when that JavaScript got invoked. All right? At the very end, we're going to use another tool called Remap Istanbul. Remap Istanbul is going to look at the coverage data and follow the breadcrumbs back to your source code that was instrumented, it will discover source maps, and it'll map all the coverage data back to where your source started. And then we blow people's minds. Everyone ready? All right, let's do it. So I'm just going to also kind of talk you through these commits because I'm looking at the time and I want to be sensitive and leave a little bit of room at the end for Q&A. So I'm just going to look at the commit diffs and you guys can use your imagination and then we're going to run it at the very end, okay? So for init React app, all I did was blow away my source and use the tool create React app to create a React app. Who's used that tool? Holy smokes, that's like 90% of us. Kudos. So you guys are familiar. The next commit, all I did was update my package JSON, once again to invoke jest from a script I'm calling E2E. This jest config will be discovered by jest, and it will tell jest, find all of my E2E .spec.test.js files and invoke them. And I just ripped off this transform from create React app because I much prefer modern syntax over what Node is currently capable of. But since jest runs in Node, it needs to be able to run in Node, I guess. All right, last thing I added was the homepage spec. The homepage spec is going to launch a tool called Puppeteer. When the tests start, I'm going to launch a Puppeteer browser, and because I like to watch my end-to-end tests execute, I set headless to false. By default, Puppeteer is going to launch with headless Chromium, which means it usually is a lot faster. But I want to slow it down, and I want to actually make sure that I'm clicking on the right things and I'm doing the right things in the right order. So I also added slow-mo because boy is it fast. When you guys run this locally after this very last commit, I would encourage you to rip out this config and just use the default config because it's a lot faster, you know, lot leaner. When my tests are all done, I close the browser. The only thing this test does is go to localhost 3000, wait for the logo to appear, and I sure hope that the logo is there. Okay? Nothing too special going on here. It's basically a smoke test, if you know that term. Make sure that nothing really, really terrible has gone wrong. Before I build my app and start to run this end-to-end test, I want to make sure that coverage is actually correctly reported. So I added a button. Those of you guys who know React hooks, this should look pretty innocuous. Those of you who don't, just know that this is starting as an empty string, and then when the button is clicked, if math.round.math.random, whatever, is truthy, then I'm going to set the value to a new value. If there's a value, we'll use it. Otherwise, we'll say click me as the button's inner text. All right? I also, because I added functionality, I sure ought to test for that functionality. So I added an end-to-end test that makes sure that at least sometimes the button causes the text to change. I'm going to go to local 3000, select the button, and then evaluate its inner text. I would expect the text to start as click me because I haven't clicked it yet. Then I'm going to click the button, and then I'm going to get the button's text now that I've clicked it. And now it's going to be either the new text is click me or it was clicked. Either way, it's fine. I don't really care. All right. The next commit, I added a few dependencies. The dependencies that I added were cpx, nyc, remap Istanbul, and serve. cpx is just going to be used to copy some additional assets from our source to our build. nyc, we already discussed, is just the CLI that invokes Istanbul to do the instrumentation. Puppeteer launches Chrome. Remap Istanbul we'll use at the very end to generate a report based on the coverage data that we collect. And serve just serves static assets from the current working directory. Nice and simple. All right? Then we're going to build our app. Because we've got some special requirements, we can't just run React scripts build. We want to copy package JSON to the build. We want to copy package lock to the build. We want to copy all of our end-to-end to the build end-to-end. And we want to copy jest config to the build. And then I ran build, and I got everything that's in build. That was that commit. The next step, from build, run npm run instrument. Invoke nyc instrument. Tell it to instrument the static JS files and dump them into static instrumented. Okay, that's going to generate, if you guys can see, I don't know if you can see in the back, static instrumented JS. All of my built assets, my chunks, have now been instrumented into a new directory. Next commit, I've extended package JSON with a serve command. Serve is just going to start up a local Express server and serve static assets on the provided port. I want to reuse the same port that I was using for development just because this is a demo. Haha. All right. The last, this is the magic bit. All right. The last change I'm going to make to the end-to-end spec that I'm running. That browser that I launched and I created a new page, I'm going to request, or I'm going to intercept every request that that page makes. And before that request goes out, I'm going to do some custom logic. The first piece of custom logic I'm going to do is look at what URL the request is requesting. If you're requesting something at static.js, then I'm actually going to respond with a different response. So this is Puppeteer serving code to itself. I'm going to go ahead and read in from the current working directory. I'm going to replace static.js with static instrumented.js. I'm going to serve the instrumented code to the browser from the file system. If it's not for static.js, well, just continue the request as if you're requesting some other asset, because I don't know how to handle those other assets, and they're not interesting for building an end-to-end coverage report. All right. When all of my tests are done executing, I'm going to pull out the coverage data from the window. Remember, in Node, the global object is called global. In the browser, it's called window. So I'm just going to get that double under coverage variable off the window object, and then I'm going to write it to the file system. Then I still want to obviously close my browser. As a result, I get all this garbage written out to disk. And if you look really carefully, you can see these are my function counters where they started and ended all the way towards the back end here. We'll start to see some actual coverage data. It just gives me an ellipsis. Thanks, VS Code. You're really fast. All right. Now that we've got our coverage data written to disk, the very last meaningful commit, obviously I updated the README at the very end of this too, but that's not important. The last important change that I made in my package.json, I added one last npm script. E2E report is going to tell remap Istanbul to read in my E2E coverage JSON and output it to the coverage directory. I want to generate an HTML type, and obviously I don't really care how much React code I invoked. I don't really care whether object assign was invoked. I want to exclude all my node modules. I really only care about my source code because I'm egotistical. I don't know. All right. As a result, well, let's go ahead and check that out. In my build, I've generated that coverage report. If I open up index.html here, we can see in the root of my app, app.js, I only got 75% of the branches in here because my math.random rounded down. You guys might have different results when you run this locally. Trust me, it's working though. We do this at Robinson to get all of our UIs to production right now. So I know it's working. This is also a really quick and dirty way of doing it, so our solution's a little more robust. Cool. What did we learn tonight? You tell me. All right, here's what we learned. We're going to execute some tests. In order to generate a coverage report for those tests, first thing we're going to do is instrument the code by parsing it into an AST. We'll transform that AST and produce a source map so that we know this is what executed at runtime and this is where it came from. Then we'll flatten that new AST into new source code. Then we're going to run our tests, and along the way, those instrumented counters are going to be incrementing, and they're going to be writing to a global variable. When our tests are done executing, that global variable is still available, and we'll just serialize it and write it out to disk. Then we can output different reports that are optimized for different tools. This is kind of the cool extensibility point and why IstanbulJS is kind of the de facto standard for instrumenting code these days, because you can generate all sorts of different reports from the very robust coverage data that it collects. So you can generate an alcove report or an HTML report like we looked at. You can generate one that's optimized for Team City or SonarQube. Lots and lots of different reporters have been contributed to the community by the community and interoperate really well with IstanbulJS. So the very last step here, profit. Obviously, always. All right. I'll hang out for Q&A, but I've only got 3 minutes left. Like I said, go to this Git repo if you guys want a refresher. I've also got a link to this slide deck. Thanks a bunch for having me.
Awesome. Thanks, Evan.
I'm pretty friendly.
Thanks everybody for being here. See you next month. Shout outs to Anna, my co-organizer, who's super awesome, and I appreciate her. And I need to give Anna a shout out because I kind of suck at that. I also need to give a shout out to Dave, who helped us out with the food this morning, afternoon, however it's time. Thanks everybody for being here. See you next month. Thanks.
Hi, likewise.